Hi, this is Mrs. Wiederholt, and welcome to my lesson video on solving quadratic equations by factoring. In this lesson video, we are going to learn how to factor the difference of perfect squares. Now let's get started. Now, when quadratic equations are in standard form, they usually are trinomials, meaning ax squared plus bx plus c. But sometimes the b value is actually 0. And in that case, you would have ax squared plus or minus c. In today's lesson, we're going to be dealing with something very specific. It's called the difference of perfect squares. And what that means is your ax squared, both the a and the x are squared terms. And it's going to be subtraction, not plus. It's going to be the a squared times x squared minus c squared, meaning your c term is also a perfect square. And this is called the difference of perfect squares. So step number 1 for doing this is to find the square root of a squared, x squared, and c squared. And step number 2 is to rewrite in factored form. It will be in this format: ax plus c times ax minus c. And I almost forgot about step number 3. After you've got it in factored form, set each binomial equal to 0 and solve for x. Now, let's do an example. In example 1, we have x squared minus 25 equals 0. Step 1 is to take the square root of this term and the square root of this term. So let's do that. As you can see, the square root of x squared is x, and the square root of 25 is 5. So now we move on to step 2, which is to rewrite this in factored form. We do this by opening up two sets of parentheses. And inside the parentheses, we put the square root of x squared, which would be x in each one. And then we put the square root of 25 as the second term in each parentheses. Now remember, one set of parentheses will have a minus and the other one will have a plus. The reason why one parentheses will have a minus sign and the other a plus is because when you are multiplying your factors, such as in FOIL, multiplying the first terms, x times x is x squared. And if we multiply the last terms, negative 5 times positive 5 is negative 25. See how there's a minus 25 here? And then the outer and inner terms. The outer terms are 5x. The inner terms are negative 5x. Well, what is 5x minus 5x? It's 0. That's why this method will work anytime you have the difference of perfect squares. Now we are ready for the third step, which is to set each binomial equal to 0 and solve for x. So we have x minus 5 equals 0, and we add 5 to both sides so that x equals 5. And then we will also have x plus 5 equals 0, subtract 5 from each side, and x equals negative 5. So those are our two solutions. And remember, you can check this by plugging each of these in for the x, and you can see if it makes the equation true. And if it does, you have the right answers. Now let's do example 2. In example 2, we have 4x squared minus 9 equals 0. Now in this case, our a squared x squared term, we have 4, and 4 is a perfect square. So we are going to take the square root of 4x squared, which is equal to 2x. And then we're also going to take the square root of 9, which is equal to 3. So now we're ready to write it in factored form. We will have 2x minus 3 in the first set of parentheses, and 2x plus 3 in the second set of parentheses. And now we can set each binomial equal to 0 and solve for x. So in this first one, I'm now going to add 3 to both sides, and I have 2x equals 3. And then I will divide each side by 2, and I have x equals 3/2. So there's one of my solutions. Now I'm going to take 2x plus 3, set it equal to 0. Subtract 3 from both sides, and I have 2x equals negative 3. And then divide each side by 2, and I have x equals negative 3/2. And so that's my second solution. Now, if you need to go back and reread the steps for solving the difference of perfect squares, or if you want to replay this video to look over it one more time, please feel free to do so. Anyway, I hope this video has helped you understand how to solve quadratic equations when they are the difference of perfect squares, and I look forward to working with you again. Bye-bye.